The operating system provides a foundation for applications on the computer. The operating system kernel manages the resources of the computing system: execution, memory, storage, I/O. User interface functions make it easier to develop applications that users can run in order to do useful things. The operating system manages many different types of resources. Which programs execute on the CPU at any given time? The memory on the computing platform, its storage, and the input and output devices. One of the things that operating systems do is manage concurrency. Apparent concurrency can be provided by moving between several programs, executing part of one and then part of the next. Many computing platforms provide resources that allow true simultaneous execution on multiple cores and perhaps on I/O devices as well. Sending data from an I/O device to storage illustrates the complexity underlying a lot of seemingly simple applications. Data must be read from the I/O device. It will probably be put in memory temporarily, and from there, sent to storage. All of these activities are managed by the operating system. The user interface simplifies how users interact with applications and with the operating system. Here we have two windows, each of which runs a different application. These are running on top of the desktop provided by the operating system's user interface. Operating systems use accounts to keep track of users and what they are allowed to do. An account identifies a user and the requested operations of that user. The account is typically given a name, and a password is associated with it that manages access to the account. The user logs into the account, uses the system, and then logs out. The authentication process manages that access by the user using the account. Authentication controls access to the execution of programs and access to data, both to be able to see the data and to be able to modify it. A user may start a session that makes a login request to the kernel. The kernel authenticates the account and then allows the session to perform functions, for example, to run an application. We often talk about threads of execution of a program or an application. In this case, thread 1 takes the else path through this if statement. Thread 2 takes the then path through this statement. Both of the threads execute the y gets 7 statement after the if statement. True concurrency provides execution of several different operations at the same time. This requires enough hardware resources to be able to execute all of those operations simultaneously. Apparent concurrency switches between operations. Apparent concurrency allows one set of hardware to be shared among multiple applications. Programs can operate concurrently with each other. Programs may also execute concurrently with input and output operations. This UML sequence diagram shows true concurrency between process 1 and process 2. They both execute at the same time. This UML sequence diagram shows apparent concurrency. Process 1 runs, then process 2, then process 1 again, then process 2 again. This computing platform uses multiple cores to provide real concurrency. For example, Core 1 can run program P1, while Core 2 runs P2. Similarly, Core 3 and Core 4 can run their own programs. Privileges describe the ability of a program or an account to perform various types of operations. Privileges are managed by a combination of hardware and software. Those privileges may control access to memory, to I/O devices, and also to certain types of instructions on the processor. Operating systems typically run in a privileged mode that allows them to do certain things that user programs cannot. User programs request the operating system to perform privileged functions. Storage is non-volatile. Even when the power to the storage device is removed, it retains its values. Storage is very useful, for example, for file systems. Solid-state drives are a common form of storage. Hard disk drives are another form of storage. Many types of memory are volatile. That is, when you remove their power, they lose their values. Some types of memory, however, are non-volatile and will retain their values even when the power is removed. Thanks for watching.